You're welcome, friends. Yeah, this is Akada Virtual Lab. My name is Michael Awole. Today, I'm going to be talking about sequencing and in production and operations management. So I'm going to be giving a few definition of related terms, and then we want to see sequencing operations with examples. If you look at this, the first thing we will do when we want to do sequencing is to first of all load jobs. So this will bring us to the concept of loading. And then what is loading, if you may ask? This is called shop loading. It is the process of assigning jobs or teams to specific facilities. And loadings assigns the work to various facilities like divisions, departments, work centers, load centers, stations, machines, and people regarding who is going to do what. You know, when jobs arrive at the production center, which machine should be responsible for what? Which department should be responsible for a particular job, different tasks. So this is what loading will do. Not all workstations can do all kinds of jobs. Why? Because there are different specialties, you know. And the methods of loading, among others, include assignment method, transportation method, and various heuristics method. Very quickly, I am moving to sequencing operations. Now, sequencing establishes the order for doing the job at each facility. We want to know which machine should be started first. We also want to know which job should be processed first. Should it be job 1 or job A or job B should go first, and thereafter we now move to job C and things like that, you know, depending on the sequence. This is what we want to do. We want to know which order. Now, it reflects job priorities according to the way jobs are arranged in the queue or in the waiting line, depending on what the operations manager really wants or the production manager really wants, the step he really wants you to take. Or if you're a student, depending on what the examiner would like you to do. Maybe you have 3 jobs, A, B, C. The examiner would like you to possibly calculate the flow time, you know, processing jobs from A, after A to B, and after B to C. In the alternative, another examiner may prefer that you start job B first, followed by job A, and followed by job C. So this involves shop floor control, which consists of communicating the status of others and the productivity of workstations. So this is a very good example, which I want to talk about, which we are also going to resolve, which we are going to solve in this short video. Now, the following table shows 3 jobs to be produced or to be processed. Job A, B, and C. The loading function has assigned these jobs to be processed on 4 machines, designated as machine 1, machine 2, machine 3, machine 4. And then question number 1. You are requested to draw a flow chart, not a flow chart, rather, a Gantt chart. A Gantt chart will move from left to right to depict the flow of jobs. We're going to see that as we go in this video. So, using job order, number 1, A, B, C. The other one is using job order B, A, C. The third order is using job order C, A, B. But very quickly in this video, I'm going to only demonstrate moving from jobs or the order ABC. But then I'm going to leave BAC and CAB as take-home assignments for us, because I don't want this video to be too long. I just want to make it very brief so that we can quickly grab what we have to do. And then you are expected at the end of the day to compare the max span for the job sequence and base your decision on the results. So I'm going to go now to the demonstration of how this is going to be done. This is the table here. If you look at that, we have 4 columns. The first column is talking about the jobs, job A, job B, job C. And then the second column is talking about the operation number in terms of 4 operations are expected to be carried out to achieve job A. And the first operation is A1. The second operation is A2. And the third operation is also numbered A3, and so on and so forth. So which means there are 4 operations that are to be performed to be able to achieve job A. And then if you look at this, we also have machine number, where the particular machines that should be operating on each of those operations, and the number of days each of the operations must live or must stay on the machines. If you look at this, number one, job A1 is expected to be on machine 1, to be processed on machine 1 for 5 days. Thereafter, job A2 is going to come in to work on machine 3, to be loaded on machine 3 for 3 days. And thereafter, job A3 is going to be loaded on machine 4 for another 7 days. And job A4 is going to be loaded on machine 2 for 4 days. Same goes for jobs B, B1, B2, B3, as well as jobs 3, C. So let's now go to the calculation. Let's go to the Gantt chart. Gantt chart is more or less like a pictorial representation of visualization of the solution. This is what you have to do. This is where you can apparently see at a glance the flow time for the jobs. The flow time for the job. So I'm going to blow this a bit further again so that we can see it better. So if you look at this, this is what we have here. We have job M1. No, machine 1, machine 2, machine 3, machine 4. Now we have been instructed that job A1 here, it's going to run on machine 1 for 4 days. No, for 5 days. Job A1 is going to run on machine 1 for 5 days. If you look at this Gantt chart, it is labeled on top like day 1, day 2, day 3, day 4, day 5, day 6, up to day 30. Up to day 30, say. So now, if you look at this, machine 1, job A1 from our table, job A1 is going to be on machine 1 for 5 days. So day 1, day 2, day 3, day 4, day 5. That is that. You also move again also to A2, which is the operation 2 for job A. Don't forget we are processing jobs A, B, and C. Job A to B to C. So A2 now. After job A1, job A2 will begin. Job A2 will be on machine 3. We look at that. Will be on machine 3 for 3 days. This is machine 3. You mark that. A2, the first day, second day, the third day. So that is that. But mind you, if you are moving from machine 1 to machine 2, you have to look at the flow for the jobs. Job A, at the end of the completion of job A, there is an arrow pointing to the next job, which is job A2. That arrow must connect them, and it must not flow backward. It mustn't flow backward. It has to be moving forward. Okay, we'll move on. So the third job, which is operation A3 on the same job A, is going to be on machine 4 for 7 days. So it's going to be on machine 4 for 7 days. A3 on machine 4 for the next 7 days. If you look at that, we move to the next 7 days. We count 1, 2, 3, 4, 5, 6, 7. There you go. And then the last job on the last operation, which is operation A4, is going to be on machine 2. You look for machine 2 here as well again here. Machine 2 for the next 4 days. Machine 2 here. You look at that. Machine 2 here for the next 4 days again. It must not flow backward. And you count 1, 2, 3, 4. There you go. Don't forget to connect the arrows from A3 to A4. Good. That's that. So that resolves that. Now we're going to job B. Job B now. B1. Don't forget we are using the order A to B to C. So job B1 now. Job B1 now. I'm moving from job B1 is going to be on machine 2. Job B1 it's air. It's going to be on machine 2 for how many days? For 4 days. If you look at the table, B1, 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 that's fine. And then job B2 is going to be operation B2 is going to be on machine 3 for the next 6 days. Machine 3 for the next 6 days. You would agree with me that we can go backward. Like I have said, you cannot go backward. You can go backward. That's why we're not counting on machine 3. That's why we're not counting 6 days from here. 1, 2, 3, 4, 5. We can't count because there's no more space there to occupy 6 days. So B1 here, the next available 6 days space is after the A2, after the job, the 3rd day of A2. So the next available space for it is here. So that's why we have a B2 here, B2 for the next 6 days. So B2, 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 B2 for 6 days. And then the next one now is B3. B3 is going to be on machine 4 for it's going to be on machine 4. If you look at that, it's going to be on machine 4 for, it's going to be on machine 4. B3 on machine 4. B3 is going to be on machine 4 for 8 days. Okay, that's fine. This is B3, 1, 2, 3, 4, 5, 6, 7, 8. That's good. Don't forget to connect the dots, to connect the arrows, starting from B1 to B2, and then from the end of B2 to B3, and then from B3 to B4, but then there is no B4. We only have 3 operations here. So the next thing now is to go to job C. The first job to be processed, or the first operation to be carried out in C is C1, which is going to be on machine 1 for 4 days. C1 is there on machine 1 for 4 days because A1 to A5 is already occupied. You know, column 1 to 5 is already occupied here. So in that case, in that instance, the next available space now is on the 6th day. Is on the 6th day. So we're going to C1 is going to occupy that on machine 1 as we speak here for 4 days. C1, 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 C1 for 4 days. That's fine. So C2, which is operation number 2, C2 is going to be on machine 2 for another 6 days. So if you look at machine 2, we cannot go backward here. Otherwise, we'll have started counting from here. It must flow from left to right, and you cannot be on the same line. It has to be the next available day. So, so now C2 now will start counting from here on our machine 2 for the next 6 days. 1 day for the next 6 days. That's fine. 1, 2, 3, 4, 5, 6. That's fine. And then 6-3 is going to be on machine 3. As simple as flowing also from C2 to C3. Don't forget to connect your arrow. And then that will run for the next 8 days. The first day here, the second day, the third day, the fourth day, the fifth day, that is running from C16 to column 16 to column 23. That is what we have. And then the last one here is machine 4. Machine 4. Operation C4 is going to be on machine 4 for another 2 days. And if you look at this, we can't go to the beginning here to begin to count. Rather, we have to, because the flow has to be to forward from left to right. We already have our C3 in column 23, so it cannot overlap. It has to be after that day 23. So now what we have here is on machine 4, operation C4 is going to occupy column 24 and column 25. There you go. And that is about all. And that is the max span for this problem. The max span is the flow time with the highest number of days, with the highest flow time. Max span is the flow time with the highest number of days. And this is what we have here. If you look at this, job C has the highest number of days, which is 25. So that is max span. And as you go, it's as simple as ABC. So once you are given another opportunity to get this done, what you have to do next is to see, maybe you have been given the order from B to A and to C. You have to ensure that you follow that protocol. You look at that very quickly and very well before you begin your approach. And that's about all. Now, I have other videos which, if you have not seen that, below the, you will see it below this, the comment section. You will see it in the description below. I have other videos which I already have on these, on sequencing as well, which I already have here. you can quickly go through. And there are some other videos also on full video on production and operations management and on decision theory. And like I said, I have a quick tutorial on single machine scheduling. So do well to click on that. And then don't forget to subscribe. If you have not subscribed on our channel, Academy Virtual Lab, subscribe. And then if you have 1 or 2 questions, let us know. Write it in the comment section below and like this video. Thank you. Cheers. Bye.